Hello everyone, welcome back to this channel where I solve Leetcode's problem of the day with you all. So before proceeding to the video, let me tell you about myself. I'm a guardian at Leetcode and I've solved more than 1000 DSA problems across various platforms. So I've definitely been through this grind and I consider that you are learning from someone who has been through all these things. So what makes my channel actually different from others is that I actually solve the questions with you all only. Right? It's the first time I am also seeing the question, right? It's just that I just, you know, have a gist of some idea prepared with me, right? So that's all. So when I solve with you all, you get the way that how to think about how to think of approach for this question, what kind of mistake you can make in the questions while solving, right, while writing the code and everything, right? So definitely, and if you like this video, definitely share with your friends and do like it, right? And there's no problem if you code in C++, you'll even get its code at the end. You should just stick to this video till the end to ensure that you have understood the logic, right? So let's start solving the question. So it's question number 2040. It's a hard level question and it's K's smallest product of two sorted arrays. So it's given that given two sorted arrays, integer arrays, num1 and num2 as well as an integer k, return the kth smallest product of num1 into num2, right? So here two sorted arrays are given, right? And k is given. So if you just simply store their products in an array and sort that array, so you have to return that k plus 1th element to be more precise, right? K minus 1th element actually. Okay, so you have to return that K minus 1th element if you consider 0th indexing, or kth element if you consider 1 indexing from that sorted array. Okay, so uh, so if you think of one example like this, okay, and you have been given, you are supposed to find the third element from the starting for this array, right? So what could be done? What could be done here is you simply multiply your first array elements from the second, and you have stored it in another array, and you have now sorted it, and you are just required to return this kth element from it. Here k is 3, and if I follow my one based indexing, so this is going to be my kth element, right? So this is what I'm supposed to return, right? So what if we think of its brute force approach, what would be it? Just think of it that just a minute. If I think about brute force technique, so it should be like using of nested for loop, right? I shall use nested for loop, whose in which I'll simply use for loop inside for loop, and the product which I'll get, I'll store it in an array, and I'll simply return that, sort that array, and then I'll simply return that k minus 1th element, right? Because that k element, according to the question, you have to return according to the that k is given in one based indexing, right? But in that array, you will have to follow the zero based indexing. So you will have to return the k minus 1th element, right? So if we think of the time complexity for nested loop, it's actually, sorry, log of me, it's actually O of n square, right? And if you look at the constraint of the question, both the arrays are of 5 into 10 to the power of 4 length. Like that could be the maximum length, right? So if I see 5 into 10 की power 4 का whole square, right? So you will get 10 into 10 की power 8, which is 10 की power 9, right? So when you are getting 10 की power 9, we will definitely get TLE for this. We're following the brute force technique, right? So we could just not use this brute force logic for sure. So we need to think about a different approach, right? And so can't it be using of binary search technique? Like the array is given already, you have to, the array is given in sorted way, right? And also the resultant array is also supposed to be sorted. So, right. So the sorted array gives us the idea of using this technique like binary search technique, right? So, like in one of the previous question we did, and I've even solved on this channel, you may refer to it. There was a question in which we were required to make some combinations regarding the digits, right? And we had in that also it was a hard level question and the kth element we had to return. So what we did that we simply counted the elements, okay, for every individual, and we after putting out some cases out there, we had based on those conditions, we counted all those elements and reduced it from our required k, right? So in this way, our solution was optimized. So here also, I'm thinking of using the same approach that we can count the unnecessarily non-required elements or the elements which would actually be less than my target, right? And I could, after counting them, right, and skipping those elements, I could reach to my kth element, right? So in this, I could think of two cases, actually three cases, right? The first case would be that if my element of first array is actually greater than 0, right? So if it turns out to be greater than 0, that means the element is positive. And if I multiply it with any element in B, right, like nums of 0 is greater than 0 and nums of 2 is also positive, right? So any number I multiply with my 2 into 2 consider, so it shall be 4 and it will always be increasing, right? So here I can simply check it using for loop. Uh, Here also I can simply apply my binary search and check up to where my elements are actually less than and equal to target, right? So I shall count those elements and it shall be stored in my total, right? The next case would be when my A is actually equal to 0, right? Not A actually, sorry. Your num element of first array is actually equal to 0, right? So if it is equal to 0, right? So any element you will have in your second array, right? So if you multiply 0 with any number, you will get 0 only, right? So consider that your target is actually greater than or equal to 0. So in your total, what you will do, you can simply take the all elements of your second array, right? length of second array, right? That's what you can take. Or since your target is greater than 0 and the product you are getting is actually equal to 0 due to that element in first array which is equal to 0, right? So you can simply skip these elements, right? And you can take the length of the whole second arrays, right? And the third case which could be formed is if your nums of I of 1 is actually less than 0, that means it's negative. So let me make you understand this third case by an example. Okay, so if you have and if your first array is actually equal to -1 and 0, and your second array is, consider this. Okay, and your target is 4. Okay, so what you will do, sorry, so here what you can do is, like, what you can notice here is that your this zeroth index element is -1, which is definitely less than 0, right? So if you multiply it here, what's actually happening that you are getting first -1 into 4, which is -4, and -1 into 3 is -3. So this is typically the reverse of the order which we get when our element is actually greater than 0, right? Here we are getting it in decreasing, we are getting it in increasing order when traversing from right to left. Is that clear to you? Right? We are getting an array here -3 and minus. We are getting this when we are traversing from right to left actually. Okay, so that's the only thing we need to find out. So when we will traverse from right to left, so whatever the last element would be, where our binary search will actually stop, right? So we need to find out the element between the length of the whole second array and the position where our binary search stopped, right? That is it would be nums2 dot length and where your binary search stopped, right? This shall be your total number of elements which would be under your condition, right? So this is all we have to do in this question. And we are just have to focus these three cases in this and we will simply land up with our answer. So let's solve this. Okay. So as I said, we need to create a function which would be of long type and shall be counting the elements which will fulfill the condition. Okay. And then we need one target. Okay. And then we need to store this total in a variable. And now we will simply traverse through our uh, first array, nums1 array elements. Okay. So I'll say just simply put up the cases that if A is actually equal to 0, right, and the target which we're finding is actually equal to and greater to 0, right, then total here shall take up all the count the length of the second array, right? Else if my A is greater than 0, it means it's positive. So in that case, I'll have to apply my binary search. So we'll simply apply the binary search here that L is less than and equal to R. Okay, and then we will find out our mid, which is L plus R minus L divided by 2. This is the more optimized formula for finding out the middle value. Okay, and now what we'll do is that since A is greater than 0, right? So we need to have a variable which will store the product. Okay, so we need to convert our element of A into long type so that we don't get typecasting error. Okay, so long of A into nums2 of element of mid. Okay, we'll store this and we'll now simply put up the condition that if this product is less than or equal to target. Okay, so since it is less, so we need to find out more. So we will shift our left counter to more ahead. Okay, and in else condition, what we'll do that if it is greater than 0, then we need to, you know, reduce the size of our range. That means mid minus 1. Okay, so this is the one, and then we will store the total as len L, right? Because this L counter would be the one where this product would become greater than the target, right? So we need to have this L because in zero indexing, because this L would actually be the index of the of index of that element where the product will actually be greater than the target, right? And since our array is in zero indexing, right? For it follows the zero indexing. So, for instance, if you have in zero based indexing, if you are at 2, so that means the total distance you have covered is actually equal to 3, right? And since this L would be the pointer of that element in which the target would be greater than 0, right? That means it would be 1 unit ahead, right? 1 unit more. So that's why we will store it. And in that else case, that means when your A is actually negative. So in that case, I shall take this whole, okay, and so make up necessary changes into it. As I said that if it is less than 0, then we will just swap these two conditions. Why? Because in case of negative, we get our smallest product in nums of 2 while traversing from right to left and not left to right, right? So if we get product less than 2, so we will increase our range by shifting our R to the left side, and in L case, we will reduce the range by shifting our L to the side. Okay, and here, as I said, that the difference in that two range shall be returned. Okay, and now here the final code here will be that I need to make two pointers. Okay, 1, 3, 4, 5, 6, 7, 8, 9 into 1, 2, 3, 5, 6, 7, 8. And then it will be long R. Just copy the first. Now just reduce this. Okay, so I'm taking this to get the minimum and maximum possible range of values to get because the range of the element here are very big, right? Elements that are too big. So in order to cover up all the values, I'm taking this big value. And then you need to have long answer is equal to 0. Now we'll simply apply our binary search here also. It should be r less than or equal to r. And then I'll take long type, not int type, because if I take int type, I'll get error because my ln is in um, long type. Plus, uh, there would also be one more thing. I'll simply put up the condition where I will call my function which I made. Nums1, comma nums2, comma mid. So here I took mid for of long type because in the function the my target is also of long type. Okay, so here it was required. So if it is greater than equal to k, so my answer could be equal to mid because maybe like it could find the value in this, right? And maybe it could be possible that we need to look into the smaller range, right? So I'll shift my R to mid minus 1, right? Else, if it is less than k, so definitely we need to increase our range, right? So in that case, I will just increase my range to L plus 1 and return my answer. Okay, so here I'm getting answer as 0 now output 0. So why is this happening? I did this intentionally to show you that here you have declared these variables L and R with data type of long, right? And here you are storing values in integer forms, like the constants form. So here, in order to do typecasting, you need to require to do typecasting here, right? So you need to put up L here to show that these values are actually in long form, right? So when you do this, that's when it actually gets typecasted from into long type. Now when you will run this, your answer would get accepted. So you should definitely keep this in mind while declaring such values, while initializing such variables with the values, right? So that you may avoid getting such errors. And this is accepted. Okay. So it was definitely a good question, and you should try practicing it more. Okay, go deeper into its approach, whatever I told you. Try to understand that the concept here, the cases I made here, that's positive, negative, and equal to 0. How I am, skipping the values and counting it, right? So you should definitely look to it. And here is the C++ code for the same. You may refer to it. Okay. Till then, keep learning. We shall meet tomorrow again with a new question. Till then,